Okay, so we would like to find the minimum and the maximum of the function ln of x over x on the interval from 1 to e squared. Let's see what we have here. So it's an optimization over a closed interval, which means that there are two types of candidates. The endpoints of the interval, which are 1 and e squared, and the critical points in the interior of the interval. So let's find the derivative, set it equal to 0 in order to find the critical points. So we will have f prime of x is equal to what? Quotient rule. Derivative of the top, 1 over x times x, minus ln of x times 1 over x squared. So this is the same as 1 minus ln of x over x squared. And if we wish to have f prime of x equal to 0, then that's equivalent to having this fraction equal to 0. Yes, but a fraction is equal to 0 if and only if the numerator is equal to 0. So 1 minus ln of x equals 0. And when is ln of x equals to 1? That's the same thing. That's the only time that this happens is when x is equal to e. Ln of e is equal to 1, and that's the only time that this happens. Is e inside this interval? The answer is yes. I mean, think about it this way. E is close to 2.7, 2.718, and so on. And of course, e squared is going to be a little less than 9. So, so this interval that you're looking at here is somewhere between 1 and 9, and certainly 2.7 is in there. So that deserves to be on our table. Okay, so now let's evaluate the function f of x at each of these points. Remember that ln of 1 is 0, another interesting thing to remember. So, so this is 0. ln of e squared over e squared. So how much is this? Let's see. So again, let's write this in detail. So f of 1 is ln of 1 over 1, and ln of 1 is 0, so this is 0. F of e squared is going to be ln of e squared over e squared. How much is ln of e squared? So what is the exponent to which we have to raise e in order to get e squared? I mean, this question really has the answer in it. The answer is 2. So this is 2 over e squared. So this is 2 over e squared. And last but not least, it's f of e, which is ln of e over e. ln of e, we said it's 1. The exponent to which we have to raise e in order to get e is 1. And this is 1 over e. So we get two positive numbers and 0. So certainly this is the minimum. I mean, there's no doubt about that. But it's kind of interesting to ask what is the largest of the two. This is what we're looking at. And it's not entirely obvious, exactly because e is this less than obvious number. But however, if we write 2 over e squared, if we write it as 2 over e times 1 over e, then the answer becomes obvious as to which one is the largest of the two, because this number here is less than 1. Okay, we said that e is 2.7, so this means that you have a fraction where the denominator is less than the numerator. So it's less than 1. So certainly this number is less than 1 over e. Okay, that's for sure. Which makes 1 over e the larger of the two. So this will be your maximum. And that's all we wanted. Thanks for watching.